Hi, I'm going to demonstrate my load balancing SDN project result. It will be a very short one, but I will try to just figure out what's happening behind the screen. So this is my SDN Deluxe. OpenDaylight Deluxe. Here I got the topology. So what I'm going to do is just implement my Python program and figure out whether the flows are working correctly or not. So here's my topology. So initially, let's say I am going to push the flows, let's say for the elephant flow to H1 and for the mice flow to H6. My program will calculate the bandwidth utilization and find out the minimum cost. If it find that the minimum cost is through this path, then it will push the elephant flow through this path, and the mice flow will be pushed through the other one. For this, I just want to before starting my program, I should give some sort of pinging, so at least one path have higher utilization than the other. So I just introduced a ping, and what I'm going to do is start my program. This is my program. So the source is 5. For the elephant flow, it will be host number 1, and for the mice flow, it will be host number 6. So after that, it's just mapping the topology, different topology, and making the cost computation. I'll go through it within a few minutes. So the computation is being done, and it pushes the flows. So I just want to uh, figure out some points here. I just go to the postman and find out whether there is any flow pushed, and yes, I got the flow table here. And one thing I should uh, mm, find out that so the flow should be pushed either this way or this way, because I got two available routes. One is 157 and one is 167, and the cost I got is for 157 it's 1516, and for 167 it's 1600. So this is the minimum cost path. How does I get this cost? Actually, to get this cost, I just use this rest command and find out, let's say the openflow 7.1, it's actually port number 1 of Ethernet port 1 of openflow 7, that is for this one. So I got, let's say I got something called bytes here. So this is transmission bytes and received bytes. So in total, I can get the bandwidth that is being used. Transmitted plus received. So what I have done is, in my command, actually in my program, I found out the bandwidth that is being used, and then after a few moments I just find out the utilization. Let's say um, tx plus rx is equals to 5 for one moment, and after 5 seconds it's become 10. So what's actually utilizing throughout this 5 seconds? It's actually 10 minus 5 equals 5. So this is my cost. This is my cost. If the cost is less, then I can tell that this is the minimum cost path, or this is the least cost path than the other. So this is my logic in figuring out this least cost path. And after that, I just pushed the flows through the least cost path for elephant flow. So from the switchport mapping, I can find that the port corresponding to the OpenFlow switch 5 is actually port number 1. So the elephant flow will be pushed through port number 1 of Open V switch 7. So here's my open flow this is my flow table actually. So let's see whether the flows are pushed correctly or not. Here is my open flow 7, that means OVS 7. So for the let's first see the elephant flow. Yes, this is the elephant flow destined to 10.0.1, and the output node connector is 1. So this is the perfectly what we actually wanted to do. And for the elephant flow, it should be the other one, that is that is the port corresponding to the obvious switch 6. It should be port number 2. Let's see whether it is okay or not. This is the mice flow, and yes, this is the port number 2. So the flow table is perfectly okay. Now I'm just going to check it out to my Wireshark. Here is my mini edit. So this is my Wireshark. This is the Ethernet port 1. So let's start it. Ethernet port 1 of S7. So you can see there is actually nothing except the LLDP. So when I start pinging 10.0.0.6, which is actually the mice flow, it shouldn't affect much on this port, because it has been pushed to the other port, that is 10. That is the port number 2. I can figure it out through this prompt. Yes, from here. Let's stop it and then start. Oh, sorry. So here in the port number 2, 10.0.0.6 and 10.0.0.5, these two hosts are having ping and ping reply. So the flows are pushed to this way, and let's see when I ping the other way. So when I ping to the elephant flow, it should the traffic should flow through this path. So 10.0.0.1. So yes, here we got the flow through this path. Ethernet port 1. This actually matches with the flow table, and if we go through Ethernet port 2, then you can find it's actually destined for the elephant flow, sorry, the mice flow. So the flows are actually subdivided with two different ways, and the program is working fine. That's it.